Now let's dive into an essential concept for metadata management in Snowflake: concurrency. Concurrency is all about how Snowflake handles multiple users accessing and modifying the metadata at the same time. Think about it. At a given moment, thousands of users could be running queries, creating tables, or updating permissions. If concurrency wasn't handled properly, you'd have to raise conditions, corrupted data, or system crashes. To manage this, Snowflake uses two key techniques. Number one, optimistic concurrency control. Number two, snapshot isolation. Let's start with optimistic concurrency control. Unlike the systems that lock a resource when being modified, Snowflake allows users to make changes without blocking each other. And here's how it works. When you begin an update, you get a local copy of the metadata. You make changes, and when you're ready to commit, Snowflake checks if another user has already modified it. If no changes were made by the other user, your update goes through. If the changes were made, you are asked to retry your transaction with latest metadata. This system ensures smooth concurrency without locking users out, which would otherwise cause bottlenecks. Next is snapshot isolation. Snapshot isolation means that every query sees a consistent snapshot of the metadata from the moment it starts. For example, if you run a query and someone drops a column mm, midway through, your query still sees the original version of the table. This guarantees consistency for every query. Even if thousands of users are making changes, if your query won't be affected. It also enables features like time travel because Snowflake can maintain multiple snapshots of metadata and roll back to specific point in time. Both OCC and snapshot isolation are made possible by FoundationDB. It provides transactional consistency required to support these concurrency techniques. So in short, Snowflake's concurrency model allows thousands of users to work in parallel while still maintaining accuracy, consistency, and isolation. This is critical for multi-tenant systems like Snowflake.